peut-être d'ailleurs le dernier. Presque 2 ans. Merci. Et puis, donc, depuis presque 2 ans. Et on est content de le faire au moins en présentiel cette fois-ci. C'était cool de le faire en Zoom la dernière fois, mais c'est quand même un peu mieux ici. En plus, on a pizza et bière et autres boissons soft. En tout cas, merci à ContentSquare de nous héberger. Donc la prochaine fois, on va peut-être zapper. Je pense qu'en décembre, ça va être un petit peu mort. Mais malheureusement, je pense qu'il y aura des restrictions. En janvier, il y aura des chances qu'on fasse quelque chose. Peut-être Raphaël. Mais ouais, soit du Spark, soit peut-être du .NET. J'ai aussi quelques petites choses dans les cartons. Donc voilà, donc profitez bien de ce moment, en tout cas, avec nous. Et puis avec Jonas, pour faire du front-end pour une fois. On n'en a pas fait beaucoup, je pense, dans les autres années. Je regarde Marc, mais je pense qu'on a fait quelques fois, mais pas des tonnes. Ouais, 3, ouais, c'est ça. Donc ouais, profitez pour une fois du front-end avec Jonas. Thank you for your presence here. Maintenant, on fait le petit mot pour content.
Merci Jean-Philippe. Donc aujourd'hui, bonsoir à tous. Aujourd'hui, nous sommes accueillis par ContentSquare. Juste 2 mots sur ce que ContentSquare fait. ContentSquare, le produit de ContentSquare permet aux marques d'analyser le comportement et les expériences digitales des utilisateurs de nos clients. On fait ça en collectant beaucoup de données comme des clics ou des mouvements de souris, en analysant ces données pour comprendre où on peut améliorer des sites de nos clients. Donc, côté front, notre équipe front, en 2 mots, donc, elle est responsable de la collection des données. Et pour collecter les données, il y a quelques challenges, notamment, j'essaie de changer de slide. Voilà, donc il y a quelques challenges. Donc, notre code JavaScript, elle est installé sur les sites de nos clients. Ce sont des grands comptes, comme Orange, par exemple, et on ne peut pas se permettre que leur site tombe. Donc, les enjeux qu'on a, c'est surtout la fiabilité et la performance de notre tag. Donc, ça, c'est un sujet qui est important pour nous, côté back, mais aussi côté front. Et voilà, donc je pense que c'est la présentation de Jonas va parler un peu des enjeux qu'on a aussi chez nous. Et on embauche bien évidemment de nouveaux développeurs. Merci, bonne présentation.
Okay, is there a way for me to do full screen? You know if there's a way to just do full screen? Otherwise, it's fine. It's okay. I think it's okay. So thanks, everyone. Thanks for the great intro. Thanks for organizing this, because it's been a very long time that we've done in-person meetups, and feels good to have a beer and some pizza at the end of the day, you know. So what I'm going to be talking about is kind of a subject that's more back-end focused, but it's kind of an introduction to front-end people, because there's this idea of continuous profiling, right? Like what happens to our software when nobody's looking. So this is me. I've been a software engineer at Specto now, which is a small startup that does continuous profiling for about a year. Before that, I've been at Algolia, which is just a neighbor from this space. I worked there for 4 years. I've done various kinds of things. I joined when the company was very small and kind of grew with that. I have also been a basketball coach in the previous, which was a very interesting experience. I coached 6 to 12-year-olds. Teaches you a lot about life and endurance. That's actually me on my first computer, which was, if I'm not mistaken, it was a Toshiba Satellite, which one of the first Pentium processors, and it was bought by my parents, and it had this really great game that I always kept playing. But you know, I was a very curious kid, and so I would often just sneak around and poke around the computer, what happened, you know. And so I think one day I managed to get into the BIOS settings, and then the computer just didn't boot because I clicked around too much. So what ended up happening was, you know, we had to reboot the whole thing. Someone had to get it fixed. But I was always a very curious kid, poking around things I shouldn't have. And I kind of continue doing that through my life. So actually, this is a slide that I was almost going to have to take outside of the presentation, because you see it was posted at 7:15 this time. So like I mentioned, we work as a continuous profiling company, but we were recently acquired by Sentry, which probably I'm assuming. Sentry does error collecting, and it's exciting news to be able to build profiling with the idea of bringing it to more people. Nope. So an overview of this talk. We're going to do a brief intro into profiling. We're going to look at what continuous profiling is. We're going to do a simple story about a component. And we're going to look at the JavaScript self-profiling spec, which is a new spec. And that's going to be kind of the meat of this talk, is how did the spec work? How can we get continuous profiling from browsers? We'll do a small demo and then we'll do a Q&A. So as I was thinking about how I'm going to do this talk, I didn't know how to structure the message, right? And then I thought about like, software is very much like little kids, I had 20 of them at practice. You tell them exactly what to do. And while you look at them, they do exactly what they're supposed to do. And then you look away for 2 seconds, and then there's one kid who's just like kicking the ball around, and like, you generally don't hear about it until something really breaks. And I think kids are kind of similar, every parent's going to say, oh, as long as the kid, we can hear him in the other room and he's playing, it's fine. The moment it gets silence, that's when the real problems actually happen. And software is not that different. So, as we work on software, there's, PMs are going to bring you a spec and they're going to say, oh, this is what goes into a spec, and there's always going to be things that you're going to have to assume about that, what's going to be the user input, like what's going to happen. Like you always have, as a front-end engineer, you always have those people who just like abuse specific components or parts of the software, right? And so continuous profiling actually helps us see that from the production traffic, see what's happening. And so this is kind of where most front-end engineers are, all right, we need to ship code that works correctly. And so, obviously we start with your unit tests, integration tests. Some people add benchmarks, which I've found to be kind of a double-edged sword, because oftentimes CI may run on different machines. And so what's going to happen is you're going to have noise from different hardware, and you just have to abandon the whole thing, unless you kind of manage to do it correctly. Then usually people have end-to-end tests, and then you have your error reporting, which you hear about when things break. And then you maybe have some sort of performance monitoring. But when I talk about performance monitoring here, I'm talking about system-level metrics. Backend engineers will maybe know more about this, CPU, memory, things like that, right? You have like a number, it gives you the average, and you maybe see like the distribution, right? And then the next idea is you want to have continuous profiling. So you can know how your code is executing in the production environment, like what load is it under and how it behaves under that load, right? And so kind of where we are in the front-end monitoring world is that we have production bug. When we ship production bugs, you get a stack trace and that's it, right? But there's often performance problems that you see all over here that we have no visibility into, unless users complain. And if you're lucky, people are going to complain. But if you're not lucky, they're just going to go away and just use a different product. So the expectation is we don't want to just ship software that just works. It has to work. It has to work fast enough or slow for nobody to notice, right? And so the kind of a golden rule in front-end engineering is you have about 16 milliseconds to paint a frame, on a 60 hertz refresh rate device. The new iPhone and I think the Pixel 6 have 120 hertz screen, so your budget pretty much gets halved unless you want to introduce frame drops. And so that's kind of what we're working with. So the idea is that we want to shift all of the problems soon into the cycle of when we're building. Let's say you're building a feature, you want to have errors happen soon. You want to know if there's a problem with certain components before it gets released, right? You want to know, and you want to know that for runtime errors, but you also want to know it for performance problems, right? And the worst that can happen is you work on a feature, you release it, and then 2 weeks later, someone comes back and says, oh, like this actually doesn't work well. It's kind of broken. And then you have to go all the way back while you're working on maybe already a different project and fix it, right? Context switching is very expensive if you're an engineer. And so, minimizing that is key. So how does profiling help with all this? First of all, profiling is not a new idea. One of the mainframe computers, the IBM 360, had a kind of a sampling profiler that would record the program status word. After that, some people wrote a paper called Atom, which was a system for building customized program tools, which basically allow you to do instrumentation. This is kind of how it looked like. It was a 64-bit register, which you could use to see what's the next instruction that's going to occur, and some other little things, which, if you think about it, is already kind of what sampling profilers are today, but very, very basic. Right? So if you're interested in very much, if you're very interested in profiling, this person, Brendan Gregg, he works at Netflix. He's a performance engineer there. Systems Performance is a great book. There's also a book on BPF, so Berkeley Packet Filters. I really encourage you to read it. It's full of good ideas and just solid foundation on how to build and think about software. So, as we're building, you probably have something like this in your company. There's a massive dashboard somewhere, right? There's so many things there, and usually usually we have different dashboards because different teams take care of different things, right? And so it's kind of a mess, and it takes a while to get around. But the whole idea of dashboards like this is that we want to have context into what our system is doing. We want to know what's happening, and we want to, when things go bad, we want to know that there are places we can look at, And so Alan Kay, I don't know if you know him. He was one of the engineers at Xerox PARC. Great person. I really encourage you to watch some of his talks. He said that a change of perspective is worth 80 IQ points. And so when you think about something like a production error, right, you may think that, let's say you're a backend engineer. Something's causing a problem with your application. You look at all the metrics, things look fine, but you're looking at the wrong place because someone just used your server to just deploy another application there, and it's just consuming all the resources, right? And so that brings us kind of to continuous profiling, right? Like, why do we want to do it, and why? So I told before that the first profiler was on the IBM 360, and that was sort of a sampling profiler, because the idea of continuous profiling is that at a set interval rate, you're going to be collecting information about the system. And usually that information is things like stack traces, samples of the execution stack of your program. And why do you want to do that on production traffic, right? Well, first of all, usually the problems happen in production. The critical problems always happen in production. You want to have a real-time view of what's happening, and you want to have a reproducible context. So if you think maybe sometimes the problem may happen in production, but you can't reproduce it in development, it may not be possible. So what you want to have is you want to see how your system behaves in that production environment. So sometimes this is kind of how, this is a screenshot from our Spectre dashboard. This is a UI where we collect traces, and you usually have different ways of visualizing this. If you have a lot of traces, you can have sort of heat maps that allow you to show more data. But clearly you have an outlier there, right? And these are kind of the things that you won't see if you're looking at averages. So if you look at, for instance, if this was an average metric, it would probably be doing pretty fine. But there's actually a big problem that's happening with that code. And the way we visualize profiles is we use flame graphs. I don't know if everyone's familiar here with flame graphs. You're basically displaying the stack that was happening at that current sample, or however you want to display it. And then there's other things like differential flame graphs, which you can see here that we have in our Spectre dashboard, where you can see how a certain trace has evolved over time. And so in this case, you can see this is a trace that was an outlier. You can see that on the right, there's a large count of new frames that have occurred. And that's actually because there was sort of an infinite loop that the program could enter into, and it would render something a lot of times. So as I talk about profilers, I'm going to briefly explain the difference between a sampling profiler and more of an evented type profiler. And there's many different ones. I've even seen approaches where people are trying to patch the interpreter to do things in the, I think it was a Java project, and they would run it in development. So to be able to collect profiles. That's not production profiling, but still, I think it's an interesting approach. But to understand the profilers, there's actually, you need to understand the two concepts behind profiling. And those are, there's a concept of you want to measure, and then there's a concept where you want to debug. And when you measure, you want to have an idea of how long something takes. But when you're debugging, you want to have precise traces of what's happening. And the two profilers differ. So the one that's used for measuring is a sampling or a statistical profiler. That's used to interrupt the program and to look at the current stack trace of the program. It's usually it's usually very little overhead because it doesn't interrupt it doesn't hook itself into low level calls like system calls and things like that. So because of that, it's less accurate, but it's usually, I would like to say, it's always the one that's being used in production environments because of the little overhead that it has. And if we look at a simple example, you see on the left, there's, let's say we run a Fibonacci, you're going to have two sample events, which are going to happen at 100 Hertz rate. So at 10 milliseconds and at 20 milliseconds. So if it happens at 10, then this on the right, what you see is going to be the actual sample that you're going to be collecting. And you can see that you're missing some amount of data. But the idea is that if you gather enough of these samples, you can recreate a sort of an accurate sample without introducing too much overhead. And then the other one is the instrumented profiler. And this is a profiler that usually hooks itself straight into the program. So it can sometimes rewrite the application bytecode. And it works something like this. You're going to have, when you're entering a method, you're going to be registering that. And then once you return, when you pop off the stack, you're going to go down. So great. But sadly, none of this exists for browsers. In JavaScript, we're kind of left to our own. So you're going to often see people who are injecting timers in different places and then trying to measure that. The problem with that is that first, it's only ever going to be as good as the engineer who's instrumenting the code, who knows where to look. The second problem is it's never giving you the detail information of which function is actually spending the time. And it's just a pain to maintain. Code changes all the time, and you don't want to be thinking of, oh, my timer is going to be here and then I have to move it, right? So an idea that I often see this when we're designing components and things like that in the front end world is you're going to have someone who's going to say, oh, we need a table. It's going to have 4 fields, small search problem, but there's so many problems that can actually happen here. First, you're going to have users who are going to abuse the amount of rows that this can have. Typically always happens in SaaS companies. You have an endpoint that allows you to build something and someone just does it like 10,000 times and then the page just doesn't render. You may have a field subscribed on, which you end up parsing every time you render, things like that. And then, you always have functionality like filtering and searching, where it's so easy to create unnecessary intermediary data structures that cause performance problems that you really need to have a system to monitor these things. So I don't know if any one of you has followed React and Vue support some sort of profiling thing, which they try to instrument rendering steps. So because they have a scheduler, they control when things render, so they can measure how long a component took to render, how long it took to set some state and things like that, right? The problem with that is there's so many production problems that happen when you're not setting state and when you're not re-rendering things. Maybe you're just computing something, and it's taking a lot of time. So it is a good step forward, and I think it was kind of a base for what Facebook did afterwards, which is they actually introduced the spec. And then the next, is it coming forward? I think it froze. Oh, yeah. So people also do weird things where like they'll write decorator methods. They'll write decorators to instrument their code and recreate the stack. This is a way to do your own instrumented profiler, and it's usually something that's not a good idea. you're introducing a lot of overhead. You're calling the time function all the time, and it's again painful to maintain. So what do? We collect system metrics and we call it a day. We wait for people to complain and then we fix it. You know, visually complete, page load time, time to first byte, all the web page vitals from Google, everything. All you see is an average, and you have distribution, and that's pretty much where we stop with things. But you know, again, people shove performance .now call, which is a high resolution timer, into everything. So they try to measure things on their own. Usually they're going to shove it into things like BigQuery, and then, you know, be querying the data on their own. Leaves a lot of problems for people to misunderstand the data, because they're generally just looking at the wrong place. And then at the end of the day, you know, our platform is a massive moving target. You know, JavaScript engines keep evolving, things keep changing. So maybe something that you worked on may have just became super slow because someone just decided to not optimize that function anymore. This is my favorite thing that I saw is on Stack Overflow. It's like, oh, you know, someone said, oh, what's the fastest method to do this? What's the fastest way to do it? And then someone comes in, oh, you know, I tried benchmarking your answer and I got a very different result. You know, that's just to give you an idea. I have a benchmark just to show you how much it can actually, things differ. And then just think about all of our dependencies, right? Like today, like modern JavaScript apps have tons of dependencies. And so when we ship products, how can we be sure that we're shipping quality products, right? How can we be sure that we're not introducing problems by using other people's code? It often happens, and that's why we need to be careful about it. So that's pretty much where the JavaScript self-profiling proposal comes in. It's a CPU profiler. It's a sampling-based profiler. The whole draft is being pioneered by some people from Facebook, and it's basically the idea to be able to have that information in JavaScript. So the current status is that the API has shipped in Chrome. There is no signal from Firefox, and there's a negative signal from Safari. So it's not very promising, but there's a good support from web developer community who really want to have this thing. So I'm kind of quietly confident that something good will happen. Maybe not quickly, but I'm hoping. The problem with Safari, why they're negative, is that they're enabling their profiler disables some optimizations that the JavaScript engine does. And so what happens is you end up penalizing the whole application while the profiler is running. The other problem is timing attacks. Those of you that are not aware, that's always, every time we have a spec, anything about performance, there's always problems with timing attacks. The idea behind timing attacks is that by deducing the timing of how long things take, you can narrow down on maybe the identity of the user, things like that. And so you kind of compromise the security of the application. So, but there's still ways you can enable it, right? So currently, if you want to enable it, you need to set a cookie, document policy cookie called self-profiling. And this will signal that the API is available and that you can test it. The way it works is you can instantiate a profiler with a sampling interval. Currently, the slowest time you can use is 10 milliseconds. I don't know exactly how it works, because I know that, for instance, sampling intervals, usually they advertise that it's 100 milliseconds, but it's usually 99 milliseconds. That is in order to avoid lockstep sampling. So you're not sampling at the same time, so you can get a better idea of the application. And then you have your buffer size, which is how many events can you collect before you stop the trace. So you can stop the trace on your own, or it'll stop when the buffer is full. Some things to consider here is that the traces can be very large. You can easily get to something like 100 kilobytes, and then actually sending that over the wire to the backend may be a penalty. The spec is actually written in a way where the amount of stack information can be compressed really well. But still, it's something to keep in mind, right? That's a typical trace that a typical profile that you're going to collect. You're going to have a dictionary of frames, a dictionary of resources. You're going to have samples and you're going to have stacks. And we're going to go through each and every one of them just to give you an idea of what kind of information they contain. So obviously a frame is the function frame that was executed, right? You're going to have the name, the resource ID. So that's going to be pretty much the file that it belonged to, the line at which it occurred, and the column where the function started. The line and the column can be empty if you're executing some native code. And so obviously it's not there. A sample, if you remember from before on the timeline, a sample is a point in time that signals what kind of stack was belonging to that sample, and stack ID points to the sample, points to the stack, and you can then rebuild your entire frame. We're going to have a look at all of it. So I know it can be very confusing because it took me a while to deconstruct. And a stack is pretty much a pointer to a frame, and a frame then points to all of the parents that were executed at a time. So it's pretty simple. So as you can see, like, because they use sort of a stack ID, it can happen that you can have multiple stacks at different times that are the same, but you kind of assign a single ID so you can point to the same place. So you kind of like deduplicate a lot of the information. And this is a more visualized approach. So you can see on the left, you have the stack ID 0, and on the right, basically two of the same stacks are going to point to the same stack ID, and you can rework your way down. So if you wanted to build a call tree from a trace, you have to iterate over all the samples in the order. You need to check if there was a associated stack and kind of work your way down. This is very much pseudocoding. There's much more that goes into this, but just to give you an idea of how the whole format looks like. So I'm going to do a quick demo. I'm going to show you a flame graph from Specto actually, and we're gonna try and I'm going to show you how we can visualize the data. I'm assuming this works. Okay. This is the dashboard. Anyone still hears everything? Good. Record, you're right. So this is the dashboard that we have at Specto, and you have some high-level metrics. This is an application that we have called Trending Movies, where we just display some movies. It's pretty much an application just for us. And these are the traces that are coming in. So you have the device manufacturer. You have the filters here that allow you to query some of the functionality, narrow down on specific traces, and you can then sort of view a flame graph of a trace. This is our flame graph visualizing tool. We can usually display something like 20,000 frames, and things work pretty smooth. You can have different types of visualizations and things like that. But as you can see, like when we built this, we knew that traces can be very large, but we didn't know what to account for. We stress tested. I stress tested like I think it was something like 10,000 frames to display. Not a lot, but things still work pretty well. And we shipped it, and things work well and move on, right? But what we didn't know was that there were some people who had massive stack traces. I'm talking like 30,000 frames, things like that. So way more than what we stress tested. And those visualizations were actually very poor in terms of performance. They didn't work well. And we didn't know because we had no idea about it. If we had continuous profiling, we could have knew. And so I'm going to show you one of those traces. I think it's going to be here. Probably, I think maybe this one. Yeah, let's see it. It's taking a while, huh? Right. So this is one of the traces. There's something like, I think like 25 or 30,000 frames that are happening here. And you know, you saw the previous flame graph worked fine, right? Worked fast, not a problem. But look at what happens if I click to a left heavy view here. It just, you don't see it now, but it completely froze. The whole screen is just, the main thread is completely blocked. We don't know what's happening. Right, and then we get our results. What we're doing here is we're just walking through the tree, sorting all the children of the nodes, and then redisplaying the graph. So what do we do with this, right? Well, you know, if this was in development, easy. You know, you start your dev tools, you profile the code, you find what the problem is, and actually we can probably do that. So we are spawning the dev tools. Let's try to change the view up. I should have started the monitoring. So let's start the profiler, click on left heavy, wait for the whole thing to process. Hopefully the M1 Max are going to help with things like this, but you never know. Okay, so we got the results. Let's have a look at what's happening. Processing profile. All right, so here you can see the thread was blocked for 5.5 seconds, give or take. We walk down the stack, we can see that, okay, what's causing our problem is pretty much calls to init vertices, and then we have a lot of garbage collection that's happening. Again, something that your timers, even if you had them, are not gonna show you, right? So if we look at the code, it's pretty simple. Pretty simple. When we want to initialize the vertices of the flame graph, we iterate over all of the frames. And because we're using WebGL to render things, what we do is we create 6 points because WebGL renders triangles. So we need top left, top right, bottom left, bottom right, top right, and bottom left. And you can see it here in the positions. That's pretty much what we're doing. And then what we're doing is we're pushing that to our positions array, right? The problem with this is dynamic arrays are great until they're not. You know, when you have to resize them, garbage collection happens, and main threads get blocked. And so what you see here is pretty much what is our problem. And it was something we could have found in development if we really stress tested it, but you know, could have been something else that was the problem. So what's the solution to this? Oh yeah, I'm sorry. How is it? Yeah, good. Is this okay? All right. So, right, the positions, and then you have the X1, right, and then we push to the vertices, and then what we do is we concat, and this here is basically what causes our garbage collection problem. We can fix this because we know how many frames our array is going to have. We can pre-compute, we can allocate an array of sufficient size, and we can use assignments instead of methods like push or concat to avoid the performance problems. And actually, let's see, this is going to be the change. So you see here, we initialize the array to the sufficient size. We run over, compute the offset, and we assign our points. If we do the same thing, oh yeah, sorry. If we do the same thing now, I'm just going to refresh, see if this all compiles, everything's fine. Live demos are always a blessing and a curse. So, right, you saw the problem we had before. Now we click left heavy. It's still not the fastest, but you can see the change, right? Still better than 7 seconds, right? But what's cool here is, you know, I showed you the profiler. I showed you the profiler from the DevTools, but that's not, you know, how you can do things. So let's go back to our code here. Let's say we're here. We're still here. What I've done is whenever I read the spec, I was like, oh, what if we use profiling to profile a flame graph? Because we have JavaScript self-profiling, we can put the profilers in our dashboard. Let me reload this. Let me reload it real quick. And I also wanted to just see how the spec works, right? I was very curious. So I built this little thing where you can click Shift P and you have a profiler here at the top of the flame graph. And so if I start the profiler, it's starting the JavaScript Self-Profiling. Now I click on the left heavy view, which is still the unoptimized view from before. I stop my trace. I can visualize the trace. And so what you're going to see is pretty much the same problem as we saw before, but from our DevTools. You see a lot of init vertices calls, line 3207, column 15. This does not support source maps, so it's not very accurate, but you see the same problem. Now, why you're seeing all these small little gaps is because there's actually a bug implementation in the Chromium where the stack is sometimes identified as empty, even though it's clearly not. But let's say the profiler ran in production, we could have enabled it when we know that people are playing with the flame graph. This is the data you would have seen on the back end. This is the data you would have seen without people telling you it gets slow, right? And I think that's really cool. I'm really hopeful that this spec makes it in. And even if we go back to our changes, we're here, right? Yeah. If we reload, run the whole thing again, we would have been able to verify that our fix actually worked. Spawn the profiler again. Let's run it. Get call order. Boom, it changed, and we can see the trace. Right. No more long calls. The flame graphs work fine. And if you were to be in charge of this code base, this would be something you can ship to production, monitor later, and know about it before people complain. Let's get back to the presentation. Share screen. Right here. Let me just put my computer back. So first of all, not everything is slow in every browser, right? So which is why you can't be sure of your fix unless you ship it to production and then monitor it afterwards, right? This is a benchmark of just making a shallow copy on an array. You can see that in Chrome and Firefox, doing a concat is slightly the same or kind of similar to just doing a spread operator, which is equivalent to a slice, but then in Safari, slice is actually way more performant, right? So I was saying before about how our platform is a moving target. We really have to, when we work with environments like this, we really have to keep everything in account. So what you've seen before is actually there was something missing, right? Because we had the stack frames, we seen the frames, but our problem was garbage collection, right? That's something that could have been missed. And this is where there's a small addition to the spec called markers. And markers are there to indicate what are actually the browser operations that are happening behind that specific frame. And those go to basically garbage collection, layout trashing, style recalculations, paint, and other. I don't know what other is going to be for. So we're going to be surprised, maybe. But as you can see on the left, we have timestamps and then we have scripts. On the left, you see the sample. So the first two samples mean that there was a script that was executing, but then the next two were spent garbage collecting. And that means about 10 milliseconds there was spent in garbage collection. Same thing with style and layout. It's very easy to make performance problems by updating style sheets, things like that, when things need to be recalculated. And so I think this is going to be a great addition to give us a more complete picture of where we are spending our performance budget. So, so far profilers are great, but there's a lot of work that has to be done in the back to support this. First of all, usually profilers are controlled. So you need to have a control in the back that says, oh, we want to actually collect profiles from this device. So usually there's a configuration server, things like that you fetch information, you send data. And there also needs to be a lot of dashboard that needs to be created, right? Be able to also just visualize all this. Like everything, profiling is a tool, and continuous profiling is a tool as well that needs to be used. So when you profile, when you debug performance issues, don't look at profiling first. Look at, oh, maybe look at the high level metrics and then work your way down, because it's very easy to spend time in the wrong place. And I think, if there's one thing I really want you to take out of this talk is that, we write software and we expect it to, we assume how it's going to behave, but it may work very differently, and it may really challenge our assumptions into how it actually works, right? And so I really think, at the end of the day, you need to ask yourself, like, how is the code that I just shipped, actually performing, right? It's a lovely photo that I was sent by my mom. So yeah, like me pressing on the BIOS, crashing the computer. Yeah, that's the gist of the talk. Any questions? Many. Oh, should I keep sharing just in case?
Oh, there's...
Whoever doesn't ask questions, no beer. Yeah, I hear you. It's okay. I'll repeat the question otherwise.
Yeah. Okay. So you talk about the size of the generated data that needs to be uploaded to the backend.
Yeah.
Is there a solution or some way? You talked about compression, but
yeah, there's also a spec. It's called compression streams, which allows you to, instead of sending the data in a single chunk, to actually compress it using like kind of like deflate or like a gzip format, and then send it over the wire. I'm assuming I would obviously want to test what the compression ratio is going to be on those traces. I haven't done that, but something that probably has to be tested.
Because if you profile for, I don't know, 10 seconds at 100 hertz,
yeah,
and you need to send it from a mobile with an average connection.
Sure.
I'm not sure you will get it. So.
Yeah. So what we do, Specto, we primarily work on Android and iOS. What you've seen was an experiment that I done. We have the same problem on mobile when we collect traces. And so what we try to do is, first we try to batch traces, to duplicate as much information as we can. We make sure we don't send information when, for instance, if the device is low battery, network antennas use a lot of CPU. And so we try to kind of build heuristics around it. Obviously, nothing is perfect. I actually, to be fair, I don't know what the ratio of dropped traces is right now, and I don't know how many we drop, but I'll have a look and I'll maybe get back to you on that.
Okay, thank you.
Thanks. So my question is, are there some other tools to visualize all this data?
Yes, there are plenty of flame graph tools. I haven't found one that visualizes JavaScript traces so far, but there are plenty. There's actually someone recently who did something called Profilerpedia, which is actually, there is a lot of information there about the different tools, because there are so many different formats of tools too, that people have built tooling around conversion of one format to another so that you can visualize information. There's a great tool called Speedscope, which we've actually used for a while. It's open source. It was built by an engineer that works at Figma. Also WebGL based, works super fast. That's kind of the best one I've seen so far, and supports a lot of formats.
Which one, sorry?
Speedscope.
Speedscope.
Yeah.
Thanks.
Thank you for the presentation. My question was about the profiling spec. You said that the line and source file are not supporting source maps. How useful is actually a profiling that does not rely on the actual source code?
I think at least having the function name is helpful. Like you've seen in our case, we managed to fix something. The other problem is it would have worked. It would have worked if we didn't use like a build, like a Webpack that just kind of mangles everything together. And
yeah, if you don't write TypeScript and not Webpack and don't use React, it actually works. But who does that?
I think it's useful to a certain degree, and I think maybe there's going to be work that's going to be done there to improve it.
I mean, because basically to use the profile, you need to get the source maps, and you need to have access to actual sources to point to the real code. So that means the only people that can actually use that are the companies that have the backend expertise to do the profiling, the front-end expertise to collect their source maps and their source codes. So basically, Facebook can use it, and mostly Facebook.
So actually, a lot of people end up uploading source maps to the server. For instance, in the case of Sentry, if you want to have errors, front-end errors, you also upload source maps. And so you could probably deduce the information from that. It probably wouldn't be too hard. I'm hoping it wouldn't be too hard.
Okay, what's the first? So I'm not I'm not sure to understand exactly how it works, the communication to send the traces. So
It's manual. It's
so you from the backend you say I would like to profile this device.
No, right now it has to be initialized in user land. So it has to be let's say if you were to want it to have a toggle on when you want to run it, you would need to, for instance, query a backend, or maybe when you serve the JavaScript file or the document, set a cookie profile true, and then read the cookie and run.
Okay, so maybe you can control this from the backend by sending this this cookie and then these resources to the device. Okay.
Yeah.
Okay. Do you have more information about the issue with Safari? Because you said about the some optimization that are disabled by,
So from what I understood, there's a comment on the spec somewhere. What they said is that their profiler currently uses about 5% overhead, and it disables some optimizations. I'm assuming things like hot path, optimizations. I'm not sure exactly which ones.
So basically, when we do the sampling and the stack, it's using the runtime, the JS runtime to do that.
Yeah.
So it's maybe not really CPU, but more about what the runtime is
what's
able
executing.
to execute. Yeah.
Mm-hmm.
Okay.
Yeah. It's going to be interesting to see the approach. Like I said, like I've seen some people in mobile world, they patch the interpreter, a very wild approach. But I'm assuming there's going to be some movement there, and we're just going to see how it evolves, if it even makes it into the spec.
Okay. So for exporting the flame graph, maybe you can use the some text format. So maybe from what you get from the traces, you can export to a text format, that the collapse format for the flame graph. Yeah. Then you can build the flame graph from that with other tools.
We don't currently support exporting because we do the visualization on our own. It's also always nice to keep users using your own product. But I worked on that flame graph. Ideally, you have a flame graph that works well. There's obviously so many very complete flame graphs out there that you want to. So I'm assuming there's going to be some sort of an export feature that we add just for the simplicity of people using it.
I had another question. Does the spec actually cover non-main thread work, like service workers, other workers?
I think there was a discussion. Currently, it does not. I think there was some discussion about leaking information. Again, I would need to check, but there's discussion about it. It does not currently.
So if you have on your page a service worker that mediates everything and creates bottlenecks, you would never see that with a profiler like this.
The nice part is that the service worker doesn't run on the same thread, so it's very hard to block.
Yeah, but when you're using a network proxy, it's very easy to block all the requests.
Well, right now you don't see the requests in it's purely the stack that you're going to see. You don't see network requests. You probably could. You could pull, because there's APIs that allow you to pull the network requests and just see the duration. So we could enrich these traces with network data. There's an API,
but it's only main thread tracing right now. Yeah. So WebGL wouldn't be covered either.
No.
Anything
the calls to WebGL would be covered, but
anything GPU related would not be seen.
No, probably not.
Thank you.
unless through maybe like an interface that goes to that through there, but otherwise I don't think so.
Thank you. The question about the browser support. So you said it's supported by Chrome, and it's probably by
It's not supported. It's a trial.
It's a trial. Okay, so we can get some traces from Chrome.
Yes.
From the desktop one and the mobile one as well, right?
Yeah.
So when talking about mobile traffic, you're talking about the mobile Chrome.
Yeah. When I talk about mobile in terms of Specto, it's iOS and Android. That's what we do. And then, but you could today with this spec, you could collect information from anything running Chrome on mobile. I think they have a different build for Chrome on mobile, but you could, yeah.
But it's still only for the Chrome traffic, right?
Yeah, yeah, yeah.
Okay, I see.
Yeah.
Now, okay, so and what is the timeline of the spec? So when no one knows.
Soon could be 10 years.
Okay.
I don't know, but there's a lot of push for it. Obviously, a lot of web developers are in the dark with these kind of things, and I think it'd be a really nice addition to our developer tooling.
Okay, thank you.
The spec, yeah. You can see it's called JS Self-Profiling. It's on GitHub. It's under the web performance working group, I think, and they recently had a meeting, TPAC, when they went through all of the specs, so you can see exactly what the discussion was, like what was the problems that people had. And they actually have, I think the meetings, you can join them, like just they're all open. So yeah.
I had a more general question on the same line. I'm not familiar with how these specs work on the front-end side of things. So you said there's no signal from Firefox. What does that mean? And how come you say your developers are in the dark? It's been like
in the dark. I mean, when we write code and how it works. But I mean, like, besides specs, I think, I think the kind of thing that's happening is Chrome comes up with all these things, and it's usually kind of harder for people like Firefox and Safari to follow because they don't have the amount of resources and engineering work behind it, and so maybe they're more conservative, and they will, once this gets adoption in Chrome, they will give their opinion on if it's going to happen or not.
Okay. And so regarding the fact that there's no profiling, and you said it's as old as computing.
I mean, we don't have no profiling in JavaScript besides DevTools, which you can use in development. But
okay, all right. So it seems
else
to be working still.
Yeah, but it's the idea is you want to profile production traffic, not your development machine.
Okay. The question of the
Allez, who's left? Let's go. Good. Right, thank you very much.
Thank you.